Yesterday we had a maze worksheet on page 59 that gave us some examples of when a shape would be congruent or similar after you do something to it. So you take the pre-image and you either translate, reflect, rotate, dilate, and then the question is the resulting image congruent or similar? What key word did you look for to say it's similar?
Dilation.
Dilation. You should have noticed a pattern that the only time an object should be similar is if a dilation has occurred. And that's because it results in the same shape, but different size. And that's because of the dilation. Congruent figures are same shape, same size. And then examples of this would be translate, rotate, reflect. When we covered those transformations, we talked about how a safety net was that when you were done graphing it, you should notice it was the same shape, same size, because we were doing that on purpose. Now we have same shape but different size every time. Because of the dilation resulting in similar figures, there's some math behind this, which brings us to this paper, page 60. We're going to talk about just similar figures on this sheet, how to work with them, and you should be able to take a pair of similar figures and find the missing side lengths by setting up proportions. So let's look at the top that has some notes. Similar polygons, or similar figures. If you recall, polygons with the same, polygons that are similar have the same shape but different size. Because it's the same shape, that would mean that the corresponding angles are congruent, I'm abbreviating, and the corresponding sides, now if it's a different size, then the sides can't be the same length, right? They have to be different lengths, but they are proportional. So this is really important right here. Understanding that similar figures means the angles that correspond have to match, and the sides that correspond have to be proportional. Proportional refers to the scale factor. The ratio of corresponding sides is called the scale factor. We've already worked with scale factor. We've worked with dilating shapes when given the scale factor. We've worked with finding the scale factor from a picture where the shape has already been dilated. If polygons are similar, then their perimeters are also proportional. Perimeter, meaning the distance around the shape. Let's refresh you on scale factor. If you have a highlighter, it may be worth highlighting that the order matters on scale factor. Because if you arrange the numbers in one direction, you'll get an enlargement. If you arrange them in a different direction, you'll get a reduction. And those are two totally different things. So the order matters. How do you know what order to put it in? I taught you the trick of whatever direction you're going. If it's getting bigger, then the big number goes in the top of the fraction. If it's getting smaller, then the small number goes in the top of the fraction. So if you pay attention to the type of dilation, then it's telling you how to set up the numbers. Let's refresh right here. What is the scale factor of triangle ABC to triangle DEF? It helps to draw an arrow. So if I'm going from ABC to DEF, that would be in what? Shrink or enlargement? That is an enlargement. I'm just going to write enlarge. If it's going that direction, it's an enlargement. Now, if I said to you, find the scale factor, that means you've got to find two sides that correspond and divide the numbers in the correct order. Does it matter what two sides I pick? No, it does not matter. What does matter is they have to be the same, not side, because that sounds weird, but they have to correspond, right? If I pick, for instance, let's say I pick AB, then I have to pick what? Notice this was between the one arc and the two arcs. I have to pick DE between the one arc and the two arc. That is what matters when you're picking your numbers. Now I need to arrange them in a fraction. What did we say it's doing? It's enlarging. You'll notice that you should notice a pattern. If you'll draw your arrow to the shape it's becoming, you with me? Then that number goes on top every time. Because that's what it's doing, right? So it's enlarging, so I'm going to do 12 divided 8. Now you go to your calculator, you would type that in, and you need to get it as a reduced fraction. What do you get? And then hit math frac. Give it to me as a fraction. So to get a fraction, we'll come right here. So in the calculator, you're going to hit math frac to get a fraction
3 over 2.
3 over 2. Now let's do the next part. It says, what is the scale factor of triangle DEF to ABC? So this time I'm going from here to here. So what is that? What type of dilation is that? That is a shrink when you go that direction. Remember the trick that I told you? If you'll draw the arrow, now pick your two sides and put the number that the arrow is going to in the top of the fraction. So 8 divided by 12 as a reduced fraction is what? 2/3. It's the same number, y'all. It's just rearranged. Now the next question says, what is the ratio of the perimeter of the two triangles? What is perimeter? All the sides added up. I would like you to find the perimeter of each and write it on the inside of the triangles. And then I want you to find the ratio of the perimeters. What's the perimeter of the small triangle? 32? What about the big one? And it says to find the perimeter, the ratio, we're going to do triangle DEF to ABC. So 48 to 32. And reduce that, what do you get? 3/2. What do you notice? What do you notice? Oh, not that one. Sorry. Nothing, Miss Holcombe. I noticed nothing. What do you notice here to here? Do you notice they're the same? When you're finding the perimeter of a triangle, if you know the scale factor and you only know the perimeter of one triangle, you can get the perimeter of the other one because it's the same as the scale factor. Okay? All right. Next part should look really familiar. We've practiced this multiple times. When you have two triangles that are congruent, listen to the word I used. Congruent, meaning copies. Remember we would write congruent statements? Remember that from a week ago? We'd say triangle ABC is congruent to triangle DEF. Okay, when we're dealing with similar figures, we can write what's called a similarity statement, which is the same concept. You're tracing the letters around one shape, then you go to the other shape and you trace in the same order, but instead of writing a congruent sign, we're going to write a similar sign. So what would be, if we look up here, we have triangle ABC and triangle DEF. If I was to say they are similar, it would look like this. Notice it's like the top part of the congruent symbol only. And the actual word for that, I think, is called a tilde. I think it's called tilde. I don't know why. I don't know if she invented it or what. But it means similar. So come right here. Might even want to highlight this. Box this. Highlight this box in. And let's draw a similar notation so that you'll remember what it stands for. Okay, now let's practice being able to read a similarity statement. So right here we have two triangles. And then notice right here they're telling you, hey, triangle JKL is similar to triangle PMN. I want you to tell me what three angle pairs must be congruent, and then tell me the sides that are proportional. So what angles would be congruent? Now, would it help to look at the picture? In this case, is the picture helpful? Yes or no? Is the picture right here, can I tell exactly what is congruent to what angle over here in the picture? Not necessarily. It's a little ambiguous, right? But the statement itself is telling you angle J must be congruent to angle P. Angle J must be congruent to angle P. All right, you do the other two. Angle K is congruent to what? Angle M? angle L is congruent to now the next part is new to you. It says, tell me what sides correspond. Now, go back to the top of your paper. We said that the sides are proportional, right? Because you've got one shape small, one shape big. So we can't write sides as congruent because that wouldn't make sense. They're proportional. But if I look at the congruent statement, or similarity statement, or if I look at the picture now that I've labeled the angles, can you tell me what side corresponds with JK? JK corresponds and is proportional to P and M, right? Stand with me. What side is proportional to KL? M and N. What side is proportional to LJ? NP. So what you've just done there is listed the congruent angles and the proportional parts, the sides. That's what you've done. All right, let's do this 2 more times. Go to the back. And let's look at number 2. You're going to repeat the same thing you just did. Now, what's tricky about this one, y'all?
There's a line.
What's tricky about this picture?
It overlaps.
They're overlapped, like one is embedded within the other. So, if you're struggling to see the 2 triangles, what would be a smart technique?
Separate them.
Separate them. Can you tell me what the small one is? Y, R, and S. And then can you tell me what the big one is?
X, Y, Z.
X, Z, and Y. And then now, I should be able to see and say what marks as congruent and not. And I really don't even need to draw the pictures separate because they give me the similarity statement, but it might help you to see that second triangle. Okay, I want everybody to do these 2 right here, using the pictures and the similarity statement. The statement's probably going to help you the most. I find the statement easier to read than trying to decipher the picture. Stay with me. All right, so do those 2 right now. Okay, so look at the congruent parts and proportional parts. Check it with yours. Does anyone have any questions on listing this information? Do you find that the statement is easier to read than the picture?
Yeah.
Sometimes I find it that way too. Because then you're just looking at the order of the letters, right? Okay, now let's get to the math behind it. So, when you know that 2 shapes are similar, you know that a dilation has occurred, which means if there is a side missing, and I know the scale factor, I can find it. And the way you find it is you have to set up a proportion and then cross multiply to solve. Okay? So let's look at number 4. If the figures below are similar, with a scale factor of 2 to 3, find the value of x. When they tell you the scale factor is 2:3, what shape do you think represents the 2? The one on the left or the right? 2 to 3. Keep that in mind. The one on the left. Why? Because it's smaller, right? And then the one on the right represents the 3. you're going to set up a proportion. If you remember, a proportion is a fraction equals a fraction, right? You got a number over a number equals a number over a number. It should be equals. And then you cross multiply to solve. We've got to set it up though. Now you have to be consistent. Watch how I do this. I always start with my variables so that I can make sure it's in my proportion. I'd hate to set a proportion up and it be all numbers, no variables, and then when I go to solve, I can't solve anything because there's no variable, right? Sit up, stay with me. So you don't have to write this, but watch. So I'm going to pick x, compare it to 42, and then I have to pick 3 and compare it to 2. Do you see how I did that? Notice the order that I set it up. It has to be the same order. I went from big shape to small shape, so I have to do big shape to small shape, big number to small number. You have to be consistent. Now there's multiple ways to set it up though. You could have done 42 over x equals 2 over 3. You're about to fall asleep. You'll sit up. You sit up. Stay with me. Stay with me. You can set it up like one of 8 ways. There's like 8 combinations here. We don't have time to show all 8 combinations. But if you need help in what works every time, that would be circle the variable, compare it to what it corresponds with, then go back and keep consistency. So I did big shape to small, big shape to small. Now I'm going to cross multiply. So I get 2x equals 3 times 42. What's 3 times 42?
126.
I've run out of room, so I'm going to come over here. And then I'm going to divide by 2. What do I get? 63. All right, go to number 5. You try it. You try number 5. You will get a decimal. Just round to the nearest tenth. You will get a decimal. Just go to the nearest tenth. Does anybody want to call out their answer? That's it. So when I label my picture, it says the scale factor is 6 to 5. Where should I put the 6? In the larger one and 5 here. I always start with x. What does x compare to? As, there you go. Cross multiply. So you get 5x equals, what's 28 times 6? And you get, right? Guys, I'll be honest, it does not get any more challenging than that. It's just a matter of being able to read the shape to know what numbers you're putting together, okay? Let's go to the next one, when there's more information than we actually need.
Yeah, this one.
Or no, okay, that's fine. The next one's not the, I'm thinking of the other one. I looked ahead. Alright, so let's do 6. Notice this time the triangles are not turned in the same direction. Find the one with X. It would be side AB. Go to your similarity statement and find the side it corresponds with in the other shape. What would that be? AB corresponds to DE. I would either make them bold. Can't put congruent marks, right? They're not congruent. I would make them bold so that they stand out, or I'd get a highlighter and highlight them. So that's kind of like your anchor fraction. Okay, so X compares to 25 as, there it is. You've got to be consistent. So if I do X to 25, I have to do 28 to 20. Notice my arrows go in the same direction. Cross multiply, solve, see if you get this. Let's jump to number 10. Please jump to number 10. That would be, I think, didn't I give you all this on a second piece of paper?
Yeah, it's
okay.
on
Yeah, I stapled it. So go to number 10. What is different in number 10? We have a binomial instead of just a plain X. The only thing that changes is after you set up your proportion, you need to put parentheses around it. When you go to cross multiply, you will end up doing what? Starts with a D. Distributing. Let's do number 10. I always start with an X. Well, in this case, I have 2, so I have to be careful here. I'm just going to pick one. Doesn't matter. All right, so if I pick XD, we'll make it bold on my paper. Now I'm going to go to the similarity statement and find what side corresponds with XD. GM. I'm going to come over here and make it bold so I can keep my eyes trained on those two. Those are the two that are going to go in a fraction together. So X plus 6 compares to 36 as what? Very good. Now we have our proportion. Now it's time to cross multiply and solve. Remember this part right here. That is a binomial. That is a binomial. I'm going to draw an arrow. Use parentheses. If you forget to use parentheses on those binomials, you're going to distribute incorrectly. The parentheses are important. You're grouping two things in a unit together. All right, let's cross multiply. The 32 would cross multiply to the front. The 36 would cross multiply to the front. Now you have a basic multi-step equation to solve here. Distribute the 32. Distribute the 36. Oops. I'm gonna subtract 32x. It's really aggressive. That was an aggressive knock.
My bad.
You missed first block.
No,
Mm-hmm.
I had to go to the doctor.
Oh.
It took a whole bunch of blood out of my arm. I did not like it.
Womp womp.
Catch up. What do you get when you divide? 21. Mm-hmm.
On number 8, what would we do with the block?
Oh, number 8.
With X and
Very good. Now they're on the same shape, right? So they don't compare to each other. But if I go to set up the equation and I have an x and a y in there, can I solve it? No. So when you set up your equation, you need a scale factor fraction, which means you need a fraction of just numbers. Can you find the two sides that are just numbers? H and J is a number here, and that's in the shape that has the variables. If I come over here, HJ compares to DE. So when you go to set up your proportion, you would have to include that 9 and 15 in your fraction with X. And then do a second proportion, 9 and 15 with Y. So you're going to have two proportions here. You're going to have one for X and one for Y. I don't want to do it for you because then it takes the thinking away. But you're doing exactly what you've been doing. Right. And you'll have 9 and 15 in both of your proportions because that's the only one that has a number and a number. Now, there's one on here that is slightly, if you come down here, look down here. Number 12. Actually 11. Please pay attention right here. It does not say stop at X. It says find the length of LY. So make sure to find X, then plug it in. Number 12 gives us some information in the directions that is not in the picture. It would help to label. It says that VR is 4x plus 7. So from here to here is 4x plus 7. It also says that B to G is 18. How many triangles do you see in this picture? 2. One's embedded within the other. So it might help to draw the two triangles separately. You've got B, N, B, and then you've got B, R, G. It might help to draw them separately, label them as you see it, and then set up your proportion.